Hello again. This video topic is finding area of a sector of a circle, like a little section of a circle area. We all know if I were to draw one complete circle, the area of a full circle we all know is given by pi r squared. But we're not talking about area of an entire circle, a little section of it. So for example, if I have this circle here, let's say that's the radius of the circle, and I draw a little section of the circle. Now all my focus is finding the area of this little shaded triangle. Given I should know the angle that's created by this sector. That angle is very important because the bigger the angle, the bigger the sector, and hence the greater the area. But the area obviously cannot be more than the area of the circle. It's just a fraction of the area of the entire circle. So our theta and our objective here is to find area of this little section or sector of a circle. That formula, it's a very simple formula: half times radius squared, let's take the square of the radius, times by the angle that is made by the sector. Okay, and obviously that angle will be less than 360 degrees. Also keep in mind the big point, obviously, just like the length of the sector, theta has to be in radians, no degrees allowed. Okay, keep that in mind. Wow, it just changed my cloud. Okay, so pretty simple. I don't think that's too hard at all, just finding area of a sector. So here's an example. If you can see, we have an area, we have a circle given, radius is 16 inches, the central angle measured is 36 degrees, and the question is, what is the area of this little section? And the moment we see that, there's only one formula that we're going to be discussing: half times radius squared times theta. I'm like, all right, I can do that. Half is half. Radius sweetly given is 16. Don't forget to square that. And angle is in radians, but my angle given was in degrees. So step number one, I got to convert it to radians, which is times it by pi over 180. We did that. We did how to do the conversion. And now I'm going to simplify it here. 36 and 180, they both, I know, go into 6. And then further, 6 goes into itself one time, and 5. So this is simply pi over 5. And that's what I'm going to put here. Then I'm just going to grab my calculator. I know 16 squared is 256. And then times 3.14 divided by 5. So you can do all that on a little calculator. 256 times 3.14 divided by 10, about 80.384. And remember, this is area, so obviously area is going to be in inches, but then area is inches squared. All right, and that's how easy this is. There's no like trick or anything to it. I can give you another one, just one more. Let's say we have another circle. All right, let's say angle is, let me construct a separate form. Let's say the angle is 60 degrees, and we have to find the sector. Radius is given to be 5 feet. Okay, no need to convert the length. I mean, if it's given in inches, keep it in inches. If it's given in feet, keep it in feet. Just wait for the answer. Is the answer in feet squared, multiple choice? And that's a different deal. Okay, anyway, question is, can I find the area of this little piece of this? Half times radius squared times theta. Half, radius is 5 feet. I'm going to keep it in feet. Theta, obviously, I can't plug it in. So I'll take that 60, times it by pi over 180. One time and 3 times. So this is simply pi over 3. Okay, and we can easily do that math. 25 divided by 2 times 3.14 divided by 3. And you can do however you want to, but this is what I got. And there's 333 repeating. Again, this is area, but then area is something squared. Looks like this is feet, so you will just put squared feet. If the answer is given in meters or inches and all that stuff, then we need to do some of the conversions as well. But right now, let's assume this is an open-ended question. All right, here we go. This is how easy it is to find area of a sector of a circle. All right, see you